Let us consider the collision or the perfectly inelastic collision. Perfectly inelastic collision means suppose you have two bodies. It's called the first body m1, which is moving with a velocity, initial velocity u1, and there is another body of mass m2, which is at rest. If they collide after collision they move as a single body, which means one of the bodies stick with the other body and they move as a single body. This kind of collision is called perfectly inelastic collision. That is, this mass is m1 and this mass is m2 and they move with a single velocity, which means they are a single body because one sticks with the other. We have for any collision momentum is conserved, which means momentum before collision is equal to momentum after collision. So momentum is conserved here. So the momentum before collision is equal to m1. We have momentum is equal to mass times velocity. So m1 u1 plus this is the momentum of the first body plus m2 into second. Since the second body has no velocity, its momentum will be 0. So these two terms represents the momentum before collision. And momentum after collision, since the body is moving as a single unit, its mass will be m1 plus m2 and it is having a single velocity v. So solving this, you will get m1 u1 is equal to m1 plus m2 times v, or v you can write as m1 u1 divided by m1 plus m2. Let's keep in mind this value, final velocity of the body. So v equal to m1 u1 by m1 plus m2. So what happens to the kinetic energy? For a perfectly inelastic collision, the kinetic energy is not conserved. So we have to find separately the initial and final kinetic energies. We have the initial kinetic energy, or we write as kinetic energy initial, is equal to, we have half m1 u1 square, that is the kinetic energy of the first body, plus half m2 times 0 square, since the second body has no velocity. So initial kinetic energy will be half m1 u1 square only. What about the final kinetic energy? The final kinetic energy, we take that as KEF. So half, we have the mass m1 plus m2 times v square. V square is the velocity of the final velocity. So we can substitute the v in here. So that is half m1 plus m2 times v is equal to m1 u1 by m1 plus m2 whole square. On solving this, you will get 1 by 2 m1 plus m2 times m1 square u1 square divided by m1 plus m2 whole square. You can cancel one of the m1 plus m2 and the final kinetic energy will be, let's write it in here, KEF, final kinetic energy, is equal to half m1 u1 square u1 square divided by m1 plus m2. Clear? Which means there is a difference in the kinetic energy. Initial kinetic energy is not equal to the final kinetic energy. So the change in kinetic energy is equal to, let's represent the change in kinetic energy as delta Ke is equal to initial kinetic energy minus final kinetic energy. which is equal to, initial kinetic energy is equal to half m1 u1 square minus half final kinetic energy is m1 square u1 square divided by m1 plus m2. Clearly, you can take the half m1 u1 square term outside. So, it will be the change in kinetic energy delta Ke is equal to half m1 u1 square multiplied by, there is a 1 here, minus, since you have taken the one of the m1 from here, so m1 remains, m1 divided by m1 plus m2. On cross multiplying, you get delta Ke is equal to half m1 u1 square into, taking this to the left, m1 plus m2 minus m1 divided by m1 plus m2. So this m1 and this m1 will get cancelled. Therefore, finally, the change in kinetic energy is equal to half m1 m2. This m1 and m2 will get multiplied. m1 m2 divided by m1 plus m2 times u1 square. Clear? This is the expression for change in kinetic energy. Interestingly, you will notice that the mass will never be negative. So the half is always positive. M1 is positive, M2 is positive. Obviously, M1 plus M2 is positive. Also, the square of any term will also be positive. So delta Ke is a value which is always greater than 0. That is, delta Ke is always greater than or equal to 0. Clear? 0, it will only be 0 if u1 square is equal to 0. u1 is 0. That doesn't make any sense. So we can write that delta Ke is always greater than 0. And which means there is always a loss in energy. If you substitute in here Kei minus Ke F greater than 0, which means Kei, initial kinetic energy, is always greater than the final kinetic energy, which means there is a loss in kinetic energy. Clear?